Hello everyone and welcome to the lecture on Amazon Elastic File System, Amazon EFS. So this lecture will contain all these topics. What is Amazon Elastic File System, EFS file system types, EFS storage classes, EFS performance modes, EFS throughput modes, choosing the correct EFS throughput mode, how Amazon EFS works, how Amazon EFS works with Amazon EC2, how Amazon EFS one zone file system works, and how Amazon EFS works with AWS Direct Connect and AWS Managed VPN. So what is Amazon Elastic File System? Amazon EFS provides file storage that does not require provisioning or managing storage capacity and performance, making it serverless and fully elastic. EFS can scale up to petabytes of storage without disrupting applications, ensuring seamless growth as your storage needs increase. The service automatically grows and shrinks as you add and remove files, adapting to your storage requirements dynamically. With a simple web service interface, Amazon EFS allows you to create and configure file system quickly and easily. EFS manages all the file storage infrastructure for you, eliminating the complexity of deploying, patching, and maintaining complex file system configurations. Amazon EFS supports Network File System version 4, NFS 4.1 and NFS 4.0 protocols, ensuring compatibility with your existing application and tools. EFS is accessible across most types of AWS compute instances, including EC2, Amazon ECS, Elastic Container Service, Amazon EKS, Elastic Kubernetes Services, AWS Lambda, AWS Fargate, thus providing flexibility in integrating with your AWS environment. Amazon EFS file system types. First one is regional, which is the recommended. Regional file system stores data redundantly across geographically separated availability zone within a single AWS region. Storing data across multiple AZs ensures continuous availability even when one or more availability zones in a single AWS region is unavailable. Second one is one zone. One zone file system stores data within a single availability zone in an AWS region. While storing data in a single availability zone provides continuous availability, data loss may occur if the entire availability zone is lost or damaged. Next one is EFS storage classes. The EFS standard storage class uses solid state drive SSD storage to deliver the lowest levels of latency for frequently accessed files. New file system data is first written to this class. EFS Infrequent Access IA is a cost-optimized storage class designed for data that is accessed only a few times each quarter, providing cost savings for less frequently accessed data. EFS Archive is another cost-optimized storage class intended for data that is accessed a few times each year or less, offering the lowest storage cost for rarely accessed data. Data can be automatically moved from the EFS storage class to the EFS Infrequent Access and EFS Archive storage class by using lifecycle management, optimizing cost based on access patterns. The EFS Archive storage class is only supported on EFS file systems with elastic throughput. Once data is in the archive storage class, you cannot update the file system throughput to bursting or provision modes. Next one is EFS performance modes. General purpose mode offers the lowest per operation latency and is the default performance mode for EFS file systems. It is always used for one zone file systems and is recommended for faster performance. Next is Max IO mode, which is a previous generation performance type designed for highly parallelized workloads that can tolerate higher latency than the general purpose mode. It is not supported for one zone file systems or those using elastic throughput. To ensure your workload stays within the IOPS limit available to file systems using general purpose performance mode, you can monitor the %IO limit CloudWatch metric. Applications can scale their IOPS elastically up to the limit associated with the chosen performance mode. You are not built separately for IOPS. They are included in a file system throughput accounting. Every network file system NFS request is accounted for a 4 kilobyte 4 KB of throughput, or its actual request and response size, whichever is larger. Next is EFS throughput modes. A file system throughput mode determines the throughput available to your file system in Amazon EFS. And there are three modes: elastic, provisioned, and bursting, which provides flexibility in throughput management. Read throughput is discounted in EFS, which allows you to drive higher read throughput than write throughput, optimizing for read-heavy workloads. The maximum throughput available with each throughput mode varies depending on AWS region in which your file system is located. Your EFS file system can achieve a combined 100% of its read and write throughput. For example, if your file system is using 33% of its read throughput limit, it can simultaneously achieve up to 67% of its write throughput limit. You can monitor your file system throughput usage in the throughput utilization % graph, which is available on the file system details of the AWS Management Console. Next is choosing the correct EFS throughput mode. Use the default elastic throughput when you have spiky or unpredictable workloads and performance requirements that are difficult to forecast, or when your application drives throughput at an average to peak ratio of 5% or less. Use provision throughput if you know your workload's performance requirements, or when your application drives throughput at an average to peak ratio of 5% or more. Use bursting throughput when you want throughput that scales with the amount of storage in your file system. If after using bursting throughput you find that your application is throughput constrained, for example, it uses more than 80% of the permitted throughput, or you have used all of your burst credits, then you should use either the elastic or provision throughput. You can use Amazon CloudWatch to determine your workload's average to peak ratio by comparing the metered IO bytes metric to the permitted throughput metric. Okay, how Amazon EFS works. So Amazon EFS provides a simple serverless set and forget elastic file system. With Amazon EFS, you can create a file system, mount the file system on an Amazon EC2 instance, then read and write data to and from your file system. You can mount an Amazon EFS file system in your virtual private cloud VPC through the network file system versions 4.0 and 4.1 NFS v4 protocol. You can access your Amazon EFS file system concurrently from multiple NFS clients, so applications can scale beyond a single connection can access a file system. Amazon EC2 and other AWS compute instances running in multiple availability zones within the same AWS region can access the file system, so that many users can access and share a common data source. To access your Amazon EFS file system in a VPC, you create one or more mount targets in the VPC. For regional file systems, you can create a mount target in each availability zone in the AWS region. For one zone file systems, you create only a single mount target that is in the same availability zone as the file system. A mount target provides an IP address for an NFS v4 endpoint at which you can mount an Amazon EFS file system. You mount your file system using its domain name service DNS name, which resolves to the IP address of the EFS mount target in the same availability zone as your EC2 instance. You can create one mount target in each availability zone in an AWS region. If there are multiple targets in an availability zone in your VPC, you create a mount target in one of the subnets. Then all EC2 instances in that availability zone share that mount target. Mount targets themselves are designed to be highly available. As you design for high availability and failover to other availability zones. Keep in mind that while the IP address and DNS for your mount targets in each availability zones are static, they are redundant components backed by multiple resources. After mounting the file system by using its DNS name, after mounting the file system by using its DNS name, you can use it like any other POSIX compliant file system. You can mount your Amazon EFS file system on your on-premises data center servers when connected to your Amazon VPC with AWS Direct Connect or AWS VPN. You can mount your EFS file systems on on-premises servers to migrate datasets to AFS, which enable cloud busting scenarios, or backup your on-premises data to Amazon EFS. So I'll be explaining all three scenarios one by one in next few slides. So first one is how Amazon EFS works with Amazon EC2. So the following illustration shows multiple EC2 instances accessing an Amazon EFS file system that is configured for multiple availability zone. So in this we have AZ1, 2, 3, and the virtual private cloud has 3 AZs. And because the file system is regional, so we are talking about regional, so there is one zone and regional, right? A mount target was created in each availability zone. So you can see in AZ1 there is a mount target, and it is recommended that you access the file system from a mount target within the same AZ. So herein, for performance and cost reasons, and one of the AZ, so AZ3 has 2 subnets. So as you can see, there are 2 subnets. But in the whole availability zone, there will be only one mount target, and these 2 subnets will share that mount target. So subnet, this one is also accessing it, and this one is also accessing it. So EC2 instances will be sharing the same mount target in one AZ. But in this scenario, there is only one subnet in that AZ, which is just accessing directly. Like there is no sharing. Because there is only one subnet, and it is accessing the mount target. So as I mentioned, however, mount target is only created in only one. So in this, it's only one. Okay. Next is Amazon EFS one zone file systems. So this illustration shows multiple EC2 instances accessing a one zone file systems from different AZs in a single AWS region. So because this is one zone, so we have this is, instead of being in the region, this is at the AZ level, this EFS file system, and there is a single mount target. So VPC has 2 AZs, each with one subnet. So subnet 1, subnet 2, and because the file system type is one zone, it has a single mount target. And for better performance and cost, it is recommended that you access the file system from mount target in the same AZ as the EC2 instance that you are mounting it on. So this will give better performance and cost. But regardless, this is how it will work for Amazon EFS one zone file systems. And lastly, how Amazon EFS works with AWS Direct Connect and AWS Managed VPN. So in this case, technically both the scenarios are same, but I will talk about Direct Connect. So it can be Managed VPN also. So how to access an Amazon EFS file system from on-premises? So herein we have some on-premises server. We have a direct connection, and there's a virtual private gateway and customer router firewall. So it's all physically connected, and you can use any mount target in your VPC. So it can be any mount target in the whole VPC. If you can reach that mount target subnet by using AWS Direct Connect connection between your on-premises server and the VPC. To access Amazon EFS from the on-premises servers, you just basically add a rule to your mount target security group. So mount target security group. So here will be a security group to allow. So here to allow inbound traffic to the NFS port. So this mount target can have a security group, and you just allow port number 2049 from your on-premises server. So in this, servers will be having an NFS client, and you will just configure the DNS name to this mount target, and just if you open the security group firewall with 2049, they will be able to access the here, and all the data will be shared across machine, any EC2 instances here, here, and here. Okay, and that's all. Thanks for watching.